for all the kids to be aware, from this week onwards or from this month onwards, we will have 2 classes for Algebra 2, which is today and every Wednesday at 6 p.m. Central. So today, Monday 7 p.m., Wednesday 6 p.m. Okay? So that's a change in the schedule that we have done so that we can do more of Algebra 2. I hope everybody is aware of it. If not, this is a good information to get started with. Alright? Is everybody okay with that or no? Okay, cool. So we are starting with graphing the polynomial. And this is a very interesting topic. I mean, I'm not saying that I have any bias for any topic in particular, but what I'm saying is, this is one of the interesting topics that you guys can relate to. Now, we all have learned what is a linear equation, why it is called a linear equation, all that fancy stuff we have talked about. I will just give a quick rundown of that and then we'll jump on to graphing polynomials. Okay, so if again, I'm not trying to kind of create any boundary between you all, but Ifsa is the one who's always on video whenever she is not in person. So that's why I recommend you guys to be on video so that she doesn't feel lonely in the class. At the same time, it gives me a better way to interact with you guys. Again, I'm not mandating that, but it's prescribed. Okay? So we are starting with graphing a polynomial. Everybody can hear me okay, right? Yeah? Okay. So now first let's start with what do we know about a linear equation. Linear equation, as we all know, is nothing but a situation where you have one or more variables, let's say 2x minus y equal to 15. This is called a linear equation because the maximum power to the variables is 1. Here x to the power is 1, y to the power also is 1. So maximum power is 1. And when you can create a table with possible x and y values and plot that in the coordinate plane, you will see that it creates a line for us. That is why it is called linear equation. So any linear equation draws a straight line for us in a coordinate plane. Everybody is aware of it. Again, I'll keep on asking that question just to make sure that you guys are with me. Yeah? Dishali, Datta, Vaibhav, so now everybody okay, right? Anika okay? Yes, sir. Now, we are trying to go beyond the linear equation. And that is when we talk about polynomial. So, in the simplest or the lamest way, if I try describing what is a polynomial, see, I have 2 kids with the video on. That makes me very happy. Alright, so when we talk about polynomial, we are talking about equations, let's say, we are talking about an equation which is certainly not a linear equation, meaning it has one or more of the variables have power more than 1. As per the copybook, if I say 4x plus 3y equal to 15, is this not a polynomial? Yes, it is a polynomial for sure because it has more than one term. But mostly from a usage point of view, you will see that there is a very thin line between these two. Okay, whenever you say linear equation, we keep that in a different group. Things like this, what you are seeing here on the board, which has maximum power to the variable is 1, and this is a polynomial because it has power more than 1. And so when we talk about polynomial, we'll probably refer to things which have more power to the variable more than 1. Let's say okay, this has power more than 1. Now when we try graphing it, You will do the same way. You will create a table with possible x and y values, and you'll take all those combinations and plot those points. And I'm just making it up, okay? I'm not creating the table right now. And what you will observe is, when you have a polynomial to deal with, and you create your x and y value, you create the combination of x and y value and try plotting those points on the coordinate plane, it is not a straight line. So polynomial never represents a straight line. It will be a curve. Be it something like this, be it something like this, or be it something like this also. Okay? So everything that doesn't form a straight line is coming from a polynomial only. Yeah? So that's what I'm saying. Broadly, we'll look at two flavors. One is linear equation, which draws a straight line for us, and second is polynomial equations, which will not draw a straight line, which will be a curve of some shape and form, depending on what kind of equation we're dealing with. Is that a good starting point, everybody? No response? Yeah? Okay. So let's start decoding. How does polynomial play a role, and how do we wrap our head around that? So if I say a polynomial y equals x squared plus 6x plus 9. If you have to plot it, you have to graph it, same approach. You will create a table with possible x and y values. You will say, what if x is equal to 0? What is the value of y? When x is 1, what is the value of y? When let's say x equal to minus 5, what is the value of y? When x equal to minus 10, what is the value of y? When x is 10, what is the value of y? And you'll keep on plugging the value of x, and you'll validate or evaluate the value of y, and you will get the combinations. Okay? So far it will be okay, right? Arya, are you okay? Sana, Datta, Vasundhara, everybody okay, right? Okay. And again, I'm not asking it to get those likes or thumbs up. My main concern is to make sure that I'm not trying to run ahead of you guys and trying to convince myself that okay, I explained everything. Okay, that's why I keep asking. So it's okay, right? Yeah? Okay. So you know the basic approach. How will you graph any equation, be it a linear equation, polynomial? You will plug in the value of one variable and see what is the corresponding value of the value of the what is the corresponding value of the other variable, and you will try to plot it in a graph. So here comes the concept of zeros of a polynomial. Okay. So instead of y, I will say, let's say I have a polynomial which is a function of x, p of x, which obviously is nothing but y, which is like this. And if I say what is this is a polynomial y equal to p of x, which equals this. And if I say what do you mean by zeros of a polynomial? What does it mean to you guys? Have you come across this term before? Zeros of a polynomial. Maya, Disali, Datta, Sana, anybody? Dava, Vasundhara, anybody? Yes, go ahead with that.
Isn't that when on the x-axis, like when it's graphed, the line touches to the y value is 0 and there's like the corresponding x value to it?
Yeah, you are going in the right direction. I just want you guys to be a little more confident. It's okay to make mistakes. At least in this class, nobody is getting graded, right? Lord Nanya. So basically, zero of any polynomial simply means what is the value of the input which will get me output as 0. So this is my polynomial p of x. Implicitly we'll assume that p of x is nothing but y. Okay? So if I say 0 of a polynomial, what I'm talking about is what is the situation when this polynomial is equal to 0? So basically you are trying to solve for this quadratic equation and find out the values of x for which this whole thing is equal to 0. And then you will say, okay, this is x squared plus 6x plus 9, so that is x squared plus 6x, I can write as 2 into 3x plus 9 is nothing but 3 squared. So this is a plus b whole square scenario. A plus b whole square, if you guys remember, equal to a squared plus 2ab plus b squared. Yeah. So this is x squared plus 2x into the second term plus square root of second term. So this is nothing but x plus 3 whole square, which is equal to 0. That means x plus 3 equal to 0. That means x equal to minus 3. This is just the mathematical solution of it. Are you guys with me so far? We said this is a polynomial and we are saying what do we mean by part 0 of a polynomial? As simple as what is the value of x for which this polynomial will be equal to 0, and that's what we plugged in here and we solved for this and we got x equal to minus 3. Now what does it mean to us graphically? It means that x equal to minus 3, just remember this number, okay? So this says that what will be the situation, okay? This is 1, this is 2, this is 3, this is my x-axis, this is my y-axis. X plus 3 was equal to 0, that means x equal to minus 3. What it means is when x is equal to minus 3, so this is minus 1, minus 2, minus 3. What it means is when x is equal to minus 3 at this point, I don't know how the graph looks like, okay, we have not plotted it. But this means this is the point where this curve is meeting the x-axis. Whether it's coming from top and going this way or whether it's going from bottom and going this way, we don't know yet. We have not tried plotting the graph. But it means that this is a point where this graph meets the x-axis. Or 0 of any polynomial simply means that the point where the curve meets the x-axis. As Baba was, as Datta was explaining, right? 0 of any polynomial means the point where the graph of the polynomial meets the x-axis. Is that a fair point? Everybody with me? Nishali, Sundara, Nanya, everybody? Okay.
Yes.
So now let's make our life a little more interesting and difficult at the same time. Now let's say, let's not do kids play. You guys have grown up a little bit more than a child. So we will do something a little more interesting that suits your age or your grade or your level of intellect, whatever you call it. Now I have a polynomial which is equal to x into x minus 2 into x minus 4 into x plus 3. And somebody says, find out the zeros of this polynomial. So we have this polynomial in the factored form. You can multiply it, break it down, make it full expanded equation, polynomial expression or equation, whatever you call it. But here when you have a situation like this and somebody says find out the zeros of this polynomial, you say okay, what are the scenarios when this whole thing can be 0? This expression will be 0. When x is 0, when x is 0, this whole thing will become 0. When you multiply 0 with anything, that is 0. Okay, this is one scenario. Second scenario is when this one is equal to 0, meaning x minus 2 is equal to 0. That means when x is equal to 2. So when you have another value of x, this part becomes 0, the whole thing will become 0. And that will become 0 only when x is equal to 2. Or when this part is equal to 0. That means when x minus 4 is equal to 0. That means when x is equal to 4. Or this part is equal to 0. Meaning x plus 3 is equal to 0. which means x equal to minus 3. Are you guys with me so far? I'm just getting you guys worried more. So, in the simplest way, if I describe it, if you have a polynomial which is in the factored form and you have to find out the zeros, your simple interpretation from that would be that my whole polynomial would be a zero under these circumstances. When this guy is 0, that is one scenario. When this guy is 0, when this part is 0, or this part is 0. One of these four parts, when there is one of these four scenarios, when this element, this element, this element, or this element is 0, that is when my whole polynomial could become 0. Now, if you try relating that with, or try visualizing that in a coordinate plane, this is your x-axis, this is your y-axis. Now you are saying, okay, fine. When x is 0, this is one scenario when x is 0, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Okay? 1, 2, 3, 4, 5. Now when x is 0, this is one point. When x is equal to 2, this is second point. When x is equal to 4, this is third point. And when x is equal to minus 3, this is the fourth point. These are the points, these are the values of x, or these are the points on the x coordinate when this polynomial becomes 0. Meaning, if you have to imagine how your graph is looking like, this is one potential scenario, or it might be going from this direction also. Okay? But at least you have a fair idea of what kind of a curve or graph you are looking at. It might be, it might be a stressed graph like this. But you know what are the points where my graph of this polynomial is touching the x-axis. Whether it's coming from the top or going from the bottom, that we will figure out later. But at least this gives you a fair idea about where your graph, where your polynomial is intersecting with the x-axis. That is where this zeros of the polynomial comes out handy for us to be able to determine where my graph is touching the x-axis. Does it make sense to everybody? Sure? Datta, Vishali, Nanya, Ipsa, Sana? Sana, are you with me, beta, so far? Okay. Vasundhara, okay? Anika, okay? So, if you ever have to determine, okay, that you have a polynomial and you have to find, somebody says find out the zeros of a polynomial, the first thing that should flash in your mind is you have been asked to, or you have been tasked to find out where the polynomial is touching the x-axis. Yeah? Zero of a polynomial is only that part. Okay? So let's say if you have polynomial p of x, which you can write in factored form as x minus 2 times x plus 4. Okay? Then your first interpretation would be that okay, my polynomial could be 0 when this is 0 or when this is 0. So when this is 0, that means x is equal to 2. When this is 0, then x is equal to minus 4. So if I visualize this in the coordinate plane, this is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, minus 1, minus 2, okay. So here, your first interpretation from by looking at this factored form of the polynomial is that okay, when x is 2 or when x is minus 4, these are the points where my graph is touching the x-axis. So far we don't know yet whether this graph is going like this or going like this. But at least you know that these are 2 points where my graph is touching the x-axis. Yeah? Everybody okay so far? Okay, so we just learned what do we mean by zeros of a polynomial and how does it help us figure it out. So let's say if you have to find out zeros of a polynomial, let's say if I give you guys a scenario that okay, find out zeros of this polynomial p of x. Again, I'm using the term p because it sounds more relatable with respect to polynomial, right? I mean, I can as well say y equal to something, but I'm saying p so that we can relate to it. I mean, this sounds a familiar letter. A polynomial which is x squared plus 7x plus 6, and we are being asked to find out the zeros of this polynomial. You have to always look at how do you see zero, how do you get the zero out of it? It's very easy to say, if I can say x plus a times x plus b, if I can convert this into factored form, then we will say okay, either this is 0 or this is 0, and that gives us two scenarios. So that would be your attempt always. So if I say this is the equation, find out the zeros of this polynomial, you will say okay fine, that means I have to see if I can convert this into the factored form, something like something plus something into something, and it will become x squared plus 6x plus x plus 6. I just split this into two parts, and there is a reason for it. I am not explaining that right now. I will do it in a bit. I will take these two together, where x is common, it becomes x plus 6. I will take these two together, where only one is common, so this becomes x plus 6. And this is common element multiplied to x and 1, so we can convert this into reverse of decomposition, right? X plus 1 into x plus 6. So this whole thing converted into this form, and now we will say okay, this polynomial could be 0 when this is 0 or when this is 0, and that gives me x equal to minus 1 from this one, and it gives me x equal to minus 6 from this one. Okay? And you will say these are the zeros of the polynomial, meaning these are the points where this polynomial touches the x-axis. Yeah? So you have to always look at, if you have the polynomial in the factored form, wonderful. If not, you have to find out ways to convert that to factored form, and then everything is straightforward. Yeah? So let's look at some problems, because starting today I am using a different technique for showing the problems to you guys, so that the problems don't look like problems. I used to read the problems, right, which used to be little painful for you guys. So what I will do is, I will share my screen so you guys can see the thing firsthand. So let me share my screen so that I can show you guys the problem that we are trying to solve. Let me know when you guys are able to see the screen. Can you?
Yes, sir.
Okay. So now let me take you to the WhatsApp. So let's look at, these are the problems that I picked up for explaining you guys today, or which we wanted to practice together. Okay. Look at this graph. You guys can see the graph. What you notice here is, this is touching x-axis at 3 points, minus 5, in between minus 1 and minus 2, and at 2. Yeah? I'm not able to see your reaction, but I'm hoping that you guys can see my screen where I'm showing the graph right now. Yeah? Somebody has to unmute and say yes or no, okay? Because I'm not able to see the screen. Yeah. Now, this question says, what would be the equation of P? So again, I'll take you guys back to the previous screen. You see this graph is touching at -5, in between -1 and -2, and at 2. -5, 1.5, -1.5, and then 2. It says what could be the equation of the polynomial. So, what do you guys think? And whatever is selected right now, that is because when I was taking a screen print of that option was selected by mistake. That should not be treated as the obvious response. Okay, that is not the answer immediately. So now, right now, just because I am looking at the screen, I am not able to see who is responding, who is raising hand. So you have to unmute yourself and tell me which one looks to be the option. A, B, C or D. Has everybody taken note of this? Again, I am repeating the question one last time. This is the graph that you see, -5, -1.5, 1.5 and 2. And then you have four options to choose from, A, B, C and D, where option A is x plus 5, 2x plus 3 times x minus something, which is hidden, which is not taken the print out. I mean, the screen print that I took. Second option is x minus 5, 2x minus 3 times x plus something. And then third option is px equal to minus 5x and this. So which option you guys are leaning towards, A, B, C or D? So let me stop sharing my screen and hear your inputs first. What do you guys think? And if you guys want me to do something here on the screen, let me just for you guys to be able to recap. This was the graph. This was -5. This point was between -1 and -2, and this one was 2, I believe. Yeah, 2. This is 1 and this is 2. I know I did not do a great job when it comes to drawing it. So now you guys have to tell me what will be the equation of the polynomial by looking at this one, just this graph. Sana, Visali, Nanya, Datta, Vaibhav, Vasundhara, Anika, Aryahi, Maya, anybody? You guys are very quiet. Yes, Aryahi.
Can you go back to the questions for a second?
Okay, let me.
Answer this.
Okay. In fact, Aryahi, I have a very weird idea. Okay, let me show the screen real quick. I'll just show it for a second. And I'm actually tempted to not show it again. The reason being, you guys can you guys see the screen?
Yes.
Okay. And I'm saying that you can actually, by looking at the graph, you can create your equation by yourself. So that's why I was tempted not to share, but again, I could not dare to say straight no to Ariyahi. No, I'm just kidding. So I was saying that you can create it by yourself actually. Yes, Ipsal. What is going in your mind right now?
What?
Now I was asking, what could be the potential equation for this polynomial based on the graph that you see?
Like they're dying, so like I don't know what's going on here.
I'm sorry with that?
I'm not really sure what's going on here because my computer just died.
Oh, okay. Okay. How about Disali, Datta, Vaibhav, Vasundhara, Anika, Ananya? You think it's A?
No, C.
C. C, when you are saying, if I read that, it is P of x equal to minus 5x times minus 3 by 2x times 2x. Is that the one you are trying to get to?
Wait, no, sorry, I meant B actually.
B. So which is x minus 5 times 2x minus 3 times x plus something.
Yeah.
Okay. How about everybody else?
So I actually don't know like whole answer, but like I think it's C.
You think it's C?
Because because the answers were like cut off, so
Okay, so let me do one thing. I will write the answers here because for me, I'm an old school guy, right? So my problem is when I don't write, I don't get the confidence. First option is P of x equals, and I'll complete the equation for you guys, equals x plus 5 times 2x plus 3 times x minus 2. Okay, this is option A. Option B is Px equals x minus 5 into 2x minus 3 times x plus 2. This is second option. Third option is Px equals minus 5x times minus 3 by 2x times 2x. Option D is Px equals 5x times 3 by 2x times minus 2x. Okay? So, what do you guys think? So this was the graph given, which is intercepting the x-axis at minus 5, minus 1.5 and 2. And we have been asked to find out which of these equations is representing this graph. Yes, Dutta?
I think it's A.
You think it's A? Okay. Sana, what do you think, Dutta?
I think it's 8.
You also think it's A. Anika?
I'm not sure.
You're not sure. Disali? Yasundara? Between A or B. Okay. Aryahi, Myra? Yes, Disali.
I think it's B.
You think it's B? Aryahi?
I think it's B too.
Okay. Ipsa?
I do think it's B.
You also think it's B? Okay. So, anybody in the class who might be bothered?
so I think it's A.
You think it's A? Datta, you said it's A as well. Okay, Myra, what do you think?
I'm so sorry. Give me a minute.
Okay. Yes, Ananya,
I think it's B.
you think it's B? Okay, I will randomly pick one of you who said A to tell me why you think so. I will randomly pick one of you who said B to understand why you think so. And again, I'm not questioning anybody, I'm just trying to poke a small hole in your brain to figure out what is cooking up there without hurting anybody. Okay? So, I'll start with Datta. So, Datta, you said A. You were the first one to say A. Can you tell me why you think so?
Okay. So the x values that were given are -5, -1.5, and 2, right?
Uh-huh.
So if we use the factor method, then we get, since it says x plus 5, the when it is 0, it would become x is equal to -5, and then for the second term, what I sides, and since it's a decimal, I just did negative 1/2, and so yeah,
Okay.
then that would be negative 1/2, and the same for the back.
Okay. And if you tell me Beta, why you think it's B?
I think it's B because the x is like the x for it is like -5 on the left. For me, it's left side, and then it's -2 for on the one in the center. I think that's -2, right?
No, it's negative 1.5 actually. It's between -1 and -2.
Okay, my bad. The one thing is 30.
Okay.
But I know for the last one, the point where the line meets x is 2. So that's why I think it's B.
Okay. Now I will show you guys. So here I'll show you how my brain is processing this one. Okay. And if that sounds convincing to you guys, then that will be the way to look at it. So Maya, Aryahi, Nanya, Nishali, that's everybody. Okay. Just now look at how my brain is processing this, right? And I was trying to poke a hole into your brain. Now it's your turn for poking a hole into my brain. So when I look at this, it says when x is equal to -5, that is when the polynomial is 0. When x is equal to -3/2, that is when it is 0. And when x is equal to 2, that is when it is 0. Meaning, when x is equal to -5, that is when it is 0. When x is equal to -1.5 or -3/2, that is when it is 0. When x is equal to 2, that is when it is 0. Now, when x is equal to -5, it is 0, meaning when 5 comes to this side, x plus 5, that is when this is 0. When x is equal to -3/2, that is when this whole value is 0. That means I will bring this to this side, this becomes x plus 3/2 equal to 0, and this scenario will become x minus 2 equal to 0. Now if you look at these scenarios, these are three scenarios when x is, the whole polynomial is becoming 0. Either for this, or for this is becoming 0. That means your polynomial is going to be, one is this scenario, this one, x plus 5, or when it is x minus 2, or when it is x plus 3/2. So I'll just to make it simple, 2 into, so x plus 3/2 when I try adding, right, I'll do this way. So it became 2x plus 3/2, 2x plus 3/2. Now why I'm leaving on that? If you relate it with this equation, okay, and relate this equation that we have got with this graph, what is happening? When x plus 5 is equal to 0, that is when this polynomial could become 0. Now x plus 5 is 0, that means x plus 5 is 0, meaning x is equal to -5, which matches with this guy. When x minus 2 is equal to 0, that means x is equal to 2. This is the second point. When 2x plus 3/2, 2x plus 3/2 is equal to 0, that means 2x plus 3 equal to 0, or 2x equal to -3, x equals -3/2. That is by this point. So again, the way we learned this 0 of a polynomial was that, okay, these are the points where the value of the polynomial could become 0. So when x is equal to -5, this is the point when x is equal to -5. I just wrote it down, and from that it became, when I brought all the things together, it became x plus 5 equal to 0. This is one scenario. When x is equal to -3/2, This is what we saw in the graph. When we brought the number to this side, that is when it became 2x plus 3 by 2 equal to 0. When x is equal to 2 was the third scenario. When I brought the number on this side, it became x minus 2 equal to 0. This is what we were trying to find out. That these are the three scenarios. These are the three scenarios when one of the factors could become 0. And that is essentially what is the basic premise of a 0 of a polynomial. So, I mean, I thought in a certain way, I wrote it down and then I'm validating it. Okay, when this is 0, is it giving me x equal to minus 5? Yes. So then this approach is fine. When this is 0, that means x equal to 2. Yeah, this is correct. When 2x plus 3 is equal to by 2 is equal to 0, that means 2x plus 3 equal to 0. That means x equal to 2x equal to minus 3, x equal to minus 3 by 2, which is this point. Okay, this aligns. So there was nothing cryptic about. Only thing we had to do was, and this can get confusing. Okay, no question about it. You can do it the other way around also. You can say, okay, fine. If this is the equation, that means x equal to x minus plus 5 equal to 0. That means x equal to minus 5. Okay, this is one point. Looks okay. But if you look at this guy, when x minus 5 equal to 0, that means x equal to plus 5. It's not touching it at x equal to 5. So this should be ruled out. Yeah? Am I making sense, or am I getting you guys more confused? So Babu raised his thumb, gave me a thumbs up when I said, when I'm making you guys confused. He said, yes, you are making me confused. I'm just kidding. But on serious note, is it relatable, or you guys find it difficult? Ananya, Datta, Dishali, are you with me? Vasundhara, Aryahi, Anika, everybody okay? Okay. Now, we will not try solving this problem. I want you all to keep yourself unmuted so that even if I'm not sharing the screen, at least I would know your reaction. Okay. So let me share my screen real quick and let's go to the second problem. And this time we will not try solving it. We will just talk through it. You guys can see my screen? Yeah? And keep yourself unmuted, okay, so that you guys can interact with me. Okay? So this was the second question. This is the second question. Now you can see the question here. Vasundhara, Mayana, Riyahi, Upsa, we can see the screen, right? So this question, I'm just reading it for you guys, as you can see. A polynomial p has zeros when x equal to 0, x equal to minus 1 by 6 and x equal to minus 3. The same scenario like what we had in the previous problem, where we had a graph showing those points. Here we have the values with us. It says what could be the equation of p, and I have 3 options in this screen and 1 option in the next screen. So you guys can go to the next screen only if you are not able to find one of the answers on the screen right now. Now, give yourself 30 seconds to think through it and visualize, and then tell me what option you are leaning towards.
I think I'm going to go with A.
You want to go with A? Okay. Anybody else?
I think I'll go with A.
And you have to call out your name. I'm not seeing the screen right now. I'm just hearing the voice.
I was also going to say A.
That is Aryahi.
I was also going to say A.
You also think it's A. How about Sana?
I also was going to say A.
A. Okay. Anybody? Anika? Myra?
Yeah, I think it's A.
You also think it's A? So, I will do it this way. Let me stop this sharing first. Isha, what is it?
Yeah, I think it's A.
You think it's A? So here, when I try to solve it, okay, I have, so now it's, you also think it's A? Okay, wonderful. So when I solve it, right, this is, I'm looking at only half of the problem. Let me note it down. X equal to, what is given is x equal to 0, x equal to minus 1 by 6, and x equal to minus 3. Now whether it's A, B, C or D, I'm not really concerned about right now. How my brain is processing is, okay, I have x equal to 0, x equal to minus 1 by 6, x equal to minus 3. These are the zeros of the polynomial, meaning these are the points when it is touching the x-axis. So when x is equal to 0, if I bring 0 to this side, so x minus 0 equal to same thing, right? X equal to 0. So okay, let me waste some time here. X minus 0 equal to 0. Okay, which is nothing but x equal to 0. This is one scenario. Second is when x equal to minus 1 by 6. Let me bring everything to one side. So x plus 1 by 6 equal to 0. And third scenario is x equal to minus 3. Minus 3. So if I bring this also this side, x plus 3 equal to 0. So x equal to 0, x plus 1 by 6 equal to 0, and x plus 3 equal to 0. These are the three scenarios that we have when it could touch the x-axis. So what we are saying is, okay, so that means this polynomial is nothing but x times the second one times the third one. And again, you know that, okay, fine. Let's simplify it. X, here I will multiply 6x by 6 plus 1 by 6, x plus 3. So this became x into 6x plus 1 by 6 into x plus 3. And again, if this is 0, then you multiply 6 by 0, it will give you 0 only. So you can say, okay, fine. Divide, this is my equation. You can get rid of this. If you want to keep it, that's fine. So now, when I go back to the options we had, okay, this was my option A, x times 6x plus 1 times x plus 3. This is matching with this one. So we'll go with this. From a solution approach point of view, whenever you come across a question like this which says your polynomial has 0 at these points, or you have a graph which is showing you 3 points where it's touching the x-axis, you just put the value of x, bring everything to one side, and that becomes your 3 factors, 2 factors, 3 factors, 4 factors, whatever number of factors you have, that becomes your factors for the polynomial. Yeah? So it should be fairly straightforward, if I can say so. Does it sound okay or not convinced? Datta, what do you think of? If Ifsa is saying give me a thumbs up from 3 meters distance. But yeah, as long as you guys are comfortable, that makes me comfortable too. Okay. Anybody in the class who has smallest of the doubt? Myra, Visali, Anya, anybody? Ananya, nobody has any doubt, right? So now, okay. Now, see, now you'll see that if we are all clear with the concepts. Now see, next problem I'll show you guys, which we will not try doing, okay? I'm just sharing it for you guys to believe it. Now you have next question, okay? If you can see this one. It says polynomial P is graphed. Now you have 3 points where it's touching the x-axis. Okay? And the question says, what could be the equation of a polynomial? I am not looking for an answer from you guys, but I want to rather see your faces, see as in, again, not forcing you guys to turn on your video, but I would want to see a reaction to it. That would it be an easy problem to solve, or it's something that will bother you? Nisali, Nanya, Isha, what do you think, sir? It will be easy, right? Yeah? So whether you are given the zeros value or whether you are given the graph, both works the same way, as long as you get those values, convert them into the factor form, put the factors together, no issues. Yeah? So this was on the zeros of a polynomial. Now let me give you guys a little bit of a problem to solve. And this has more to do with factorizing a polynomial. Because it's not always been given the factored form or not in this form. You also might be given a situation to find out the zeros of the polynomial from a polynomial expression which you have to factorize. So I want to just do a quick check of how comfortable you guys are factorizing a polynomial. So here's the polynomial that you guys have to deal with. 3x cubed minus 3x squared minus 18x. I want you guys to factorize this and then find out the zeros for me. So this is a polynomial px equals 3x cubed minus 3x squared minus 18x. I want you guys to factorize this and tell me what are the zeros of this polynomial. And this is going to be your license for being done for the day today. No, I'm just kidding. I'm not going to keep anybody hostage here, but I just want you guys to try this once. And I'm trying to get a sense of how comfortable you guys are factorizing polynomials, because that is going to be a very important ingredient for us when it comes to dealing with these kind of scenarios going forward, or these kind of problems going forward. Can I assume everybody is giving it a try? Datta, Vaibhav, Sana, Anika, Disali, Ariyahi, Maya, Sundara, Ipsa. Yep. Okay. Go for it. Yes, Sundara. I'm sorry, but you have to be a little louder. I'm not sure if it's only me, but I can. One more time. You have to factorize it, because if you have to get the zeros, right? That's the only way you can do it. Datta, you're trying it, right? Okay. We have exactly 5 minutes. So
Sir, I got it.
yeah, what are those?
I got P x parentheses equals 3x parentheses x minus 3.
And can you read it for me, beta?
Yeah. So it's P parentheses x equals 3x parentheses x minus 3 and then parentheses x plus 2.
Okay. That was quick. But yeah, I would want you to validate it, review it. Yes, this is all you got it. Yeah, this is all you go ahead.
I got the same one on the board.
Okay. Vasundhara? Okay. So Vasundhara, something interesting with your microphone. When you are joining the meeting, your voice comes very feeble. When Vishal is very loud and clear. So just check on the microphone better, okay? Your voice is very feeble actually for me. I'm sorry? Okay, okay, yeah, okay. How about Datta, Anika, Ipsa, Myra, Sana? Vaibhav, how about you?
Sir, I cannot see your screen, but like based on what you said, I got like x square root x plus 3 and then x minus 2, and then the values were like x equal to minus 2, 0, and then x equal to 3.
Okay. Yeah. So let me do it. Okay. We have only a little bit of time left. Here, when we try to factorize it, again I will probably try doing the factorization techniques in the next class. Just as a recap for some of you who have not come across this or who are kind of trying to catch up on that. But here I'll just go real quick. Between these three terms, what is common is 3 and x. So let's take 3x out. When you take 3x out here, then you're left with x squared minus x and minus 6. So one factor is out. This is what you're trying to factorize. Now the method for that is x squared minus x minus 6. We are trying to find out, convert this into factor form. So here what we do is we map that with the standard form of a quadratic equation, because it's a quadratic equation. My a value is equal to 1, my b value, b is my coefficient of x, a is the coefficient of x squared, so a is 1, b is coefficient of x which is minus 1, and c is equal to minus 6. What you do is you multiply a into c, that gives you 6 into minus 6 into 1, that is minus 6. And then whatever you got by multiplying a and c, you have to find out what are the ways you can factorize this thing. So you can say minus 2 into 3, or minus 3 into 2, or minus 1 into 6, or minus 6 into 1. These are 4 factors that you can think of, which you are getting by doing a into c. Now you have to look at the combination of these factors and see which one gives you the value of b. So here b is minus 1. When you add these two, minus 2 and plus 3, it gives you plus 1. Minus 3 plus 2, how do you add these two to get a minus 1? Obviously this one looks to be the case. Minus 3 and 2. And all that we did was to find out how I can break this one. Minus 3 and 1. So I can write this as minus 3x plus 2x minus 6. So this combination that we found by comparing this with the standard form of a quadratic equation and then doing this a into c was to figure out which combination I can pick up. And minus 3 into 2, so minus 3 and 2 is the combination which will give me a minus 1 here. So that's what we did. Minus x I can write as minus 3x plus 2x. And again I'll explain these techniques in the next class to some of you who are trying to recall that. Now here these two I'll put together, these two I'll put together. And when I do that, here I can take x common, it becomes x minus 3. And here I can take 2 common, which becomes x minus 3. So this is a common factor between these two terms. So when I do reverse of distributive property, it becomes x plus 2 times x minus 3. So we got a factor for this thing. We could convert this into a factor form like this. So that means this whole thing will convert into 3x into, this whole thing will convert to this, which is x plus 2 into x minus 3. This is what I heard as an answer from many of you. So my answer is also in line with what you guys got. And once you have got this factor form, Now you know when this is 0, or this is 0, or this is 0. This is when this polynomial is touching the x-axis. Yes, Babu. Yeah, Babu, go ahead. Unmute yourself and then talk. You have raised your hand. Can you guys hear me okay? Babu is not responding. Okay. So when you can't, when you cannot hear me, that magic trick is drop off and join. This is how it works. Okay. Whenever you are having difficulty in hearing me, mostly it's because of some connectivity issue at the other end. Okay. So here the catch is, what we were trying to do was, how do we factorize a polynomial? Once you factorize this, then you know how to find out the zeros of the polynomial. Okay? So you all learned how to find out the zeros of polynomial, what does it mean to us, but we have still not learned it fully. We still have things to cover. That is when we will talk about the positive or negative intervals, and that will give us a better view of how you, just by looking at the zeros, how do you figure out whether the graph is coming from the top or going from the bottom? Okay, what is the direction of the graph? All that we'll learn in the next class or the coming classes to be more confident about the concepts related to this. Does it sound okay to everybody? No confusion, no doubt, nothing worrying you guys? If it's not worrying you guys, then I'm not worried either. Have a good night and wait for next class. Yep? Alright.
Goodbye.
Bye bye. Bye bye. Yep. Okay.